One of our exercises asks us to use the visual explain plan and compare performance of a raw query with a query that's using a common table expression. And I don't want to steal any of your fun from you. I want you to be able to do that. So I'm going to do something similar. And this is an important distinction. So you're going to need to do a little testing to make sure that or to discover whether the efficiencies, if any, carry through to a common table expression that are derived from using a view. Okay, so using the Candy database, we have this query, which is pretty straightforward. We're doing a table, a join across tables. We're going to have an aggregate function where we're counting the clients per sales agent. So, you know, you've got some sales reps working for you. They each have a client book. Let's take a look and see if our book is balanced. Do we have agents that have about the same load of clients, or who's got the most clients or the fewest clients, sort of preliminary to maybe doing some more business analysis. So we take the first query, which is given to us, use the Candy database, and then run this query. And here's what we get. So we have 4 reps, and here's the client count by rep. Pretty straightforward, not too exciting. Let's do this. Let's grab the visual execution plan, and let's make a copy of that. And I'll just drop that into a Word document. There's our raw query. Let's size that up a little bit so it's a little bit easier to see side by side. And there, that's a nice, comfortable view for our video. Put that away. And then what we want to do here is we want to come back and build this equivalent query, but using a view. And let's have the view do the heavy lifting of the aggregation, where we think most of the calculation is going to occur, and see if we get any efficiency this way. Okay, so the view that we're going to create, and I've actually already created and I've run the create view query and created the view to save a little bit of time in the video. Let's just see what it's doing. So this is just working on the client table, and it's going and finding the sales agents by client, getting the count, and giving us the group by sale agent number. If we just look at that query without running the view, this is what it's doing for us. So we've got the sales agent and the client number, but we need to do the join in order to get things like the sales agent's last and first name. We'd really like to have this not be so anonymous looking. So we're going to need to complete that. And so to complete that, it's pretty straightforward, querying against the view. So between the view plus this query, we're going to get exactly the result that is given to us by this query. And so we're just going to see if we get any performance increase. So that's going to select the last name, the first name, and the client count. Remember, we aliased that in the view. That's our aggregate function, the count of the client. The grouping's already here by the sales agent to support that aggregation. So we get a count for each sales agent of their clients rather than just a total number of clients in total. So we need that group by. And so we're selecting against that. And this is where we're doing the join so that we can add the last name and first name to the client count to get that. And let's run this. And there's the result. So just to double check, take a look at this for starting with Chavez and ending with James, 4134. Let's run the original query, Chavez and James, 4134. So I'm satisfied that we have constructed this correctly and we have the same logical result. Let's run this query against the view. And now let's take a look at our execution plan and see what, if anything, changed. So let's take a snapshot of this and bring up our Word document again. All right, so we see that the visual explain plan got a little bit more complicated. So here we have presumably what's going on in the group by is going to be happening in the view. And so it breaks out that first. And so here we just had a non-key lookup. Here the index, the grouping, and the grouping was up here. Does it matter in what order that we did this? Let's take a look at the overall query cost. So raw query is 3.85. The query cost here in against the view is 3.45. So we picked up a modest improvement. Now, will that improvement persist over time? What if these tables were a lot larger? What if there are as you might expect, the sales agent table stays relatively small relative to customers, which grow much faster? Does that make a difference? And the answer is we don't know, but these are the things we can either try to reason through looking at the way that the difference in the plan, the query execution plan is built, or we can just observe it empirically over time, and then we could consider whether or not it might warrant additional performance tuning. Are there different additional indexes that we could add? Is there a different way to structure this this query? Maybe instead of doing a group by, maybe we come in and we use a Windows function and partitioning. Are there things we can do to unwind our loops? Those are questions to answer in the future. But what we can see right now is for the tables as they exist today, we do get a modest improvement. And we're doing very much the same thing, except we're doing our grouping here on a single table before we do the join. You know, I'd like to actually run both these queries 2 or 3 more times and kind of see, you know, are we consistently getting about the same performance? Is there anything else going on with this? Because that's not a huge difference, but we do see a difference. Is it sustainable? That'd be a great thing for you to explore. Also, do we get a benefit from this being a view relative to if you were to create this as your assignment exercise as you do as a common table expression? And so there's a very good question for you to explore is, do you get better performance from a view versus a common table expression? And if you do, why might that be? So one of the things you might consider, well, gee, if I have created the view, then all of my SQL code has already been pre-compiled, so the execution plan already exists. So I save certainly a little bit of something at the execution time when the query is run. Does that account for the difference in the 3.85 cost here and the 3.45? Again, I don't know. You have to explore that. And that's one of the things that I'm inviting you to do here, because I've solved the problem or a similar problem comparing the raw query against the view. You're going to compare the raw query against the common table expression. And in doing so, you could also borrow my view and use it, or build your own and compare just for your own satisfaction. Does the view buy you anything relative to a common table expression? Certainly, we would expect that if we were to have a materialized view, one in which we build indexes against the view, and the view is therefore kind of starts to obtain the overhead of a table because it has, you know, update and maintenance requirement every time the underlying data is changed. But that might be something to consider performance-wise. Again, I'm going to foreshadow future explorations, probably something you'll explore either in a future class or on the job with regard to building materialized views in databases that support those. And just something food for thought. For now, let's focus against the question at hand, which is the raw query versus, in your case, the common table expression, or in my example, against the view. So I hope that actually opens up more questions for you than it provides answers, but that's a good thing when you're doing performance tuning, because the situation tends to be dynamic, and a lot of times there are no hard and fast answers because the underlying structures of the table, the relative table sizes, can have a profound effect on the way that the query optimizer chooses to build the code to actually solve the logic that you've expressed in your SQL. And this kind of gives you a view beneath all that abstraction. And sometimes it is important for you as a DBA, or particularly as a data architect, so sort of the lead DBA, person that is probably more responsible for enterprise performance, and probably compensated a lot better for it as well. If you're honing to be promoted beyond DBA, these are the kinds of things that you need to think about, experiment, and get to know for your organization's data, and exactly your database, including the database version, because one of the things to be mindful of is whether you're running Oracle or Postgres or MySQL, which has several different flavors of a database file system underneath it, the database engine, whether you're running InnoDB or a different database engine. All of these things are going to influence the performance, and they're things that you're going to need to have a deep enough understanding to test it on the fly, analyze your results, and then make an informed decision to keep your enterprise systems running at the highest possible performance. That's it for now. Happy exploring.